Welcome to another set of exercises, and today we are going to solve the exercises, at least some of them, of chapter 12 and 13 of the book. And we start with a relatively simple exercise in chapter 12, exercise 12.1. And exercise 12.1 asks you to consider an industry which is perfectly competitive and contains 100 identical firms which all have the same short run total cost function. And that's the function that is given here. And in question A, you are asked to compute the short run supply curve with Q as a function of the market price P. Now, given that the market is perfectly competitive, each firm is a price taker. It takes the price P as given. And importantly, we consider the short run. So in the short run, the situation is different than in the long run, which we will consider in question 12.4. But the price can be higher than the average cost. And in the short run, firms may be able to make a positive profit because entry is not possible. So what each of these firms will do independently of each other is it will set a quantity such that the marginal cost of production equals the marginal revenue, and the marginal revenue, given that the firm is a price taker, is identical to the market price P. So each firm solves the output decision, which answers the question, okay, if the firm is active, if it produces, how much will it produce? And the marginal cost is simply the derivative of the cost function that is given. So taking the derivative of this function with respect to q, we get that q squared over 100 plus 0.4q plus 4 will need to equal marginal revenue, which is the market price P. But we're not done, because the exercise really asks you to compute the supply curve as Q as a function of the market price P. And this is not what we have here. And there's a second issue. We also need to check whether the firm will produce at all, and whether it's not more attractive for the firm to shut down. So we also need to consider the shutdown decision. So we need to verify whether the price, the given price, is at least equal to the average variable cost of the firm. So, and given that the price is equal to the marginal cost, and alternatively, we need to check whether the marginal cost function is above the average variable cost function. Now we can check. We already have an expression for the marginal cost. We derived that here. And the average variable cost is, well, the fixed cost is equal to 10. The variable cost is this part of the cost function. And to find the average variable cost, we need to divide this part by q. And we arrive at the expression q squared over 300 plus 0.2q plus 4. So this is the average variable cost. This is the marginal cost that we just take from here. And we need to check that the marginal cost is higher than the average variable cost. Now we can simplify this expression. So we have terms with q squared. We put them together. We have terms with q. We put them together, and then we have constants 4. And we have plus 4 on the left hand side, plus 4 on the right hand side, so they cancel out, and we arrive at the following expression. So this condition holds if and only if this expression is greater or equal to 0. And is it? Now, in order to see that, we can easily see that quantities, they cannot be negative. So this part is always positive because we have a q squared over here. And this is also positive because quantities are not negative. So we have two positive terms or non-negative terms on the left hand side. So this inequality holds for all quantities that are greater or equal to 0. So the firm will not shut down, it will produce, and then the question is, okay, how much will it produce for the given price P? And now we have the inverse supply function P as a function of the quantities, but this is not what is asked for. We need to find a quantity as a function of prices. So we need to solve this expression for Q. And we will do that next. So in the intermediate slide we have a graph which shows you that indeed for all quantities greater or equal to 0, the marginal cost curve is above the average cost curve. So this means that the individual supply of the firm is given by the marginal cost curve of the firm. So check, this holds. Okay, so we need to write Q as a function of P. So we need to solve the quadratic equation for which this is identical to P. So another way to write this equality is to bring the P to the right hand side, such that we get Q squared over 100 plus 0.4Q plus 4 minus P is equal to 0. And we want to solve this expression. Now, this is not too complicated because we can solve it with the ABC formula that you know. And you need to recognize that the 4 minus P over here is actually can be treated as a constant because the firms take the price as given. So we have a simple quadratic equation here where we can treat 4 minus P as a constant. Now, to make it a little bit less clumsy, we multiply the entire thing with 100, which we can do without any problem, because on the right hand side we have a 0. 0 times 100 is still 0. So we can, if this holds, then this also needs to hold, where the left hand side and the right hand side are both multiplied by 100. Okay, so now we have the less clumsy equation. And now we can apply the ABC formula, recognizing that the in front of the Q square we have a 1. So that's our A in the ABC formula. In front of the Q we have a 40, which is the B. And then we have a constant term, 104 minus P. And then if we apply the ABC formula, minus B plus minus the square root of the discriminant, and the discriminant is equal to b squared minus 4 times AC. So 4 times A is 4, and 4 times 104 minus P is this expression over here. And then we need to divide by 2A. A is equal to 1, so we divide by 2. And then we have two possible solutions for the quantity as a function of price. So if we simplify this expression, we arrive at minus 20 minus 10 times the square root of P, or the quantity is equal to minus 20 plus 10 times the square root of P. Now, we know from real life that quantities cannot be negative, so this root is irrelevant because this is negative, and the relevant root here is this expression over here. But this expression is only positive if the price is at least equal to 4, because the square root of 4 is equal to 2, 2 times 10 is 20, 20 minus 20 is 0. So this is our inverse supply function, so this is the supply function, it's a function of price under the condition that the price needs to be at least equal to 4. And that solves question A. Then we move on to question B. So, on the assumption that there are no interaction effects among cost of the firms in the industry, compute the short-run industry supply curve. So, this assumption makes life pretty easy. So we have 100 firms. We have computed for one firm the individual supply function. So we now simply multiply with the number of firms active in the industry in the short run, and we get the short run industry supply curve. So we multiply the individual supply curve by number of firms n, and n is equal to 100, such that we get the industry supply curve being equal to minus 2000 plus 1000, the square root of p. And again, price needs to be at least equal to 4 for this number to be positive. And then we arrive at question C. So far we considered the supply in this industry. Now in question C, you're also given the market demand function, and we now can combine supply and demand in order to calculate the short run equilibrium price quantity combination. So that's pretty straightforward. We need to equate supply and demand in order to get the equilibrium price. So demand is given by this expression over here. The industry supply curve we computed in question B, and now we need to solve this one for the price P. So bringing all this to the left-hand side of the equation, we arrive at this expression over here, and we can divide the left-hand side and the right-hand side by 200 in order to get rid of the 200 here. 1000 over 200 is equal to 5, and 10,000 over 200 is equal to 50. So now we have a simple expression which we can simplify further. So we can rewrite it as the product of these two terms, and we arrive at two possible solutions. So the square root of p should be equal to minus 10, which cannot be the case because the square root always needs to be non-negative. So the only solution that is possible is the equilibrium where the square root of the price is equal to 5. And if the square root of a price is equal to 5, the price must be equal to 25. And with this price of 25, well, we can plug it into the demand function, and we arrive at the equilibrium quantity of 3000. So this completes exercise 2.12.1.